Is software just another component in a medical device, or does it require a completely different approach? Today, most medical devices rely heavily on software, from simple monitoring functions to complex decision-making systems. So here is the key question. What happens if software behaves incorrectly? Unlike hardware, software does not fail physically. It behaves incorrectly, under certain conditions, and this makes it much harder to control. This is why IEC 62304 exists. It defines how medical device software must be developed and managed. Why is software treated differently from hardware? Let's compare them. Hardware fails physically. It wears out. Components degrade, and failures often occur randomly. But software is different. So here is the key question. Does software actually fail, or does it behave incorrectly? Software does not degrade over time. Instead, it contains logical errors. These errors only appear under specific conditions, which means the same software can work perfectly in one situation and fail in another. This is what makes software so challenging. Failures are systematic, not random, and this is exactly why a dedicated standard is needed. So, what exactly is IEC 62304? At its core, it is a software standard for medical devices. But here is the key question. Does it define how to write code, or does it define how software must be managed? IEC 62304 focuses on processes. It defines how software is developed, maintained, and controlled. It also introduces software safety classes. These determine how strict the requirements must be. And this is important. It is not just about coding. It is about ensuring that software behaves safely in all relevant situations. So how does the software lifecycle actually work? IEC 62304 defines a structured lifecycle. But here is the key question. Is software development a linear process, or does it continue over time? The lifecycle starts with planning, defining what needs to be built and how. Then comes development. This is where the software is implemented. Next, verification. Does the software behave as expected? Then the software is released. But this is not the end. Maintenance is a critical part of the lifecycle. Because software evolves, issues are discovered, and updates are required. So the lifecycle is not linear. It is continuous. How does software safety actually get classified? IEC 62304 defines 3 safety classes. But here is the key question. What determines which class applies? The classification is based on potential harm. Class A means no injury is possible. Class B means non-serious injury could occur. And Class C means serious injury is possible. Now think about this. Should all software be treated the same way? Of course not. The higher the risk, the stricter the requirements. This affects development, verification, and documentation. And this is where IEC 62304 connects directly to risk management. What are the outputs of IEC 62304? What do you actually get from this process? First, you get structured software requirements. These define what the software must do. Then, a clear architecture and design. This defines how the software is structured. Another key output is verified software. But here is the important question. How do you know that the software behaves correctly? This is where verification comes in. You also get traceability, from requirements to implementation to testing. And finally, comprehensive documentation. All of this provides evidence for safety and compliance. Where does IEC 62304 fit into the bigger picture? Software is where requirements become reality. It implements system behavior. But here is the key question. Where do these requirements come from? They come from risk management. Hazards are identified, and controls are defined. Software must implement these controls. At the same time, everything must follow structured processes. This is where quality management comes in. So think about it like this. Risk defines what must be done. Software implements it, and quality ensures it is done correctly. What challenges arise in practice? Software development in medical devices is not trivial. One major challenge is system complexity. Software systems can become very large and difficult to manage. Another challenge is defining correct requirements. So here is the question. How do you ensure that requirements are complete and unambiguous? Traceability is also critical. Every requirement must be linked to implementation and testing. Handling changes is another key challenge. Software evolves, and updates must be controlled. And finally, alignment with risk management. Software must implement risk control measures correctly. There are several common misunderstandings about IEC 62304. One of the most common is that software safety is only about testing. But here is the question. Is testing enough to ensure safe software? In reality, it is about the entire life cycle. Another misconception is that software is finished after release. But software requires continuous maintenance. Some also think documentation is just a formality, but it is essential for traceability and compliance. Another misunderstanding is that all software has the same level of risk. This is why safety classes exist. And finally, software cannot be treated like hardware. It behaves fundamentally differently. Let's summarize the key points. IEC 62304 defines the software lifecycle for medical devices. It focuses on structured and controlled development. It also introduces safety classes based on risk. And it is closely integrated with risk management and quality processes. So here is the key takeaway. Safe software does not happen by accident. It requires structured processes, clear requirements, and continuous control. And here is a final question. What is more critical, the code itself or the process behind it? In reality, both are essential. If you want to go beyond this introduction to IEC 62304, we offer a wide range of online training programs on our website. In medical devices, we cover software development, risk management, and quality processes. We also provide training in automotive and aerospace systems. You can find the link in the video description and in the pinned comment below. If you found this video helpful, feel free to like the video, leave a comment, and subscribe to the channel. And I'm curious, do you already work with IEC 62304, or are you just getting started? And if you want to continue learning, you might also be interested in our videos on ISO 14971 and ISO 13485.